Hello everyone, I hope you all are doing great. We heartily welcome you all to our YouTube channel CAD CA Master. If you enjoy what you see, hit the subscribe button and turn on the notifications so you never miss an upload. Hello everyone, I hope you all are doing great. So in the previous sessions we had seen the free modal analysis on automotive components and the normal tuning fork. Yeah. So now today we'll see how exactly we need to do the free modal analysis on the industrial equipment components like the centrifugal pumps. Yeah. So here what I'll be doing is I'll be taking you through the model completely from the scratch, where I'll be taking the CAD model. You can download it from the internet, or if you want the files you can even ask us, so we could provide you based on some terms and conditions. Yeah. And we'll mesh the model. We'll also define the connections and the contacts. Okay, what on all the bugs you're gonna get it, or the issues you're gonna get it while defining it. So how we need to take the contacts and connections. So what are the Pbars, so how we need to connect them, how we need to define the properties for them, and then how we need to define the decks in ANSA as well as the Hypermesh, and defining the param cards, required param cards, and then finally seeing the outputs after solving the model, and then finally post-processing and checking the behavior of the model and excitation of the component, and global modes, torsion and bending modes, and the local modes also. So we'll see these all things, and yeah, so after doing the free modal analysis on the assembly, how we need to predict whether the component connections and the contacts are proper or not. So these all things we're gonna see in this particular session. Okay, well, let's get started with this. Yeah, so this is the CAD model. We'll start measuring it. Okay, you can use the surface mesh, click on the generate mesh, and you can set to auto triage, because I'll be using the triage mesh for this. So yeah, could see this is the mesh. I'm using a very fine mesh, right? So and then we have the CAD. We need to release that. Initially we had a surface, right, the CAD surface. So now it's being released. You could see this is the mesh. You can turn off the mesh, and then this is the CAD. Now just delete this CAD. So now we don't need this. So activate the FE now. So just click on the FE. Yeah. Now the thing is, we need to do some geometry cleanup. So all the fasteners, the bolts and nuts, so I'd like to remove. So I'll just switch to PID region, and I'll select all the fasteners here. Delete these, because here we are not going to take these all the fasteners into account. So instead of this, we can just apply the connections like the RB2s and RB3 wherever it is needed. And if needed, you can even apply the pretension loads. Yeah. So once you do that, next thing is here. This is the supporting plate for the mounts, right? Pump and the motor. I'm just checking the length. It is exactly 30. So what I'll do is I'll just use the offset tool, and then I'll offset top surface, because here these particular plates, no, I would like to later use for the optimization, means how much thickness I should use. Now it is 30, right? So I'd like to make it 7 or 5, or so that I can minimize the weight. So for that I would like to do that. So right now I would like to remove this complete solid mesh, and I'll just place it as shell. Okay, so I'll just offset it to a certain distance, 15.2. 30.4 was the value. Yeah, similarly here also I'll do the same. Go to offset, and yeah, select the face, just click OK. Okay, I'm just copying that face here, right? Now I could delete this one, so this is not needed for me now. Yeah, So instead of that, I'll be taking this shell element. So I'll be applying the thickness for this shell later. Yeah. So now I need to create the holes here bottom, right? So that I need to mount it properly. So for that, what I can do is I'll just project this particular uh, the hole to bottom plate. So I'll just select these two edges and these also. Even I can select these two in one particular click. I could able to project everything, and then we can delete the mesh over there. Okay, so where you would like to project, the target is the shell. So this one and this one. See, this preview is there. Just click OK. I could see. In the more action, I have selected the create parameter, so it has created the parameter, right? Yeah. So similarly, I'll just select these parameters again so that I can just project these at the bottom mesh 2, means the bottom surface 2. Target should be this face and this. Yep. So done. Now I would like to delete the mesh inside. So just go to delete, activate the macros so that it will just select this regions. Yep. So once you do that, here also I need to delete on the top faces. I'll select this. Yeah, delete, middle click. Yeah, it's done. Now I need to fill it, so I'll use the fill tool directly. Yeah, you could see the preview. This is fine. Try to do the same here. Now it is creating issue. So this automatic tool sometimes create the issues. What you can do is you can switch to a old panel, 24 panels. So go to the panels and activate the model buttons. From there we have the manual method, so it has all the options, right? So here elements fill, just select the closed option, this parameter and this parameter. So if you middle click, you have multiple options. The draft is fine here. In the methods you have fitted and other things also. Okay, so this tool will help a lot of uh, regions and scenarios as well. So I'm going to do the same for all the deleted regions. Now, so I need to apply the RBE2s. For example, I'll just show you what to do. So this phase would like to do, yeah, similarly here also. You need to finish this and then select the closed area, closed loop. Similarly, instead of here, better I should select at the bottom. That would help me to define the proper connections. So here we have the issue. So what I can do is I'll just fix it using the direct edit tool. This one and this one, done. So you can even remove this one, it is not needed. Yeah. Now again apply the RBE2 here too. So later I can delete whichever I don't want, but right now I'm simply applying everywhere. Okay, so all regions I have applied. Well, similarly you can do for all the whole region. So before that I would like to change the optimize RBE2. I have removed it because I would like to see how exactly the RBE2s are there. Okay, so yeah. Now you can connect these with the Pbar elements and you can define the properties. If needed also you can define the pretension, but right now in this particular session it is not in the scope. Yeah.
Well, so once you do that, you could see I have applied everywhere RB2. So next thing is to define the Pbars as I told. So you can just select the option. So this is the one. Okay, node to node connections you need to define. So wherever you have the RBE2s, there you select the first point as the reference and second point here so that it can define properly. So once you do that, you just need to middle click again. So it will ask you for the property definition. You can assign the properties later. I'll simply create a dummy property here. Yeah, so now I'll simply click OK. So let it be like Pbar. I need to define area, inertia 1, inertia 2, and the other factors too. Later we'll define it. Yeah. Well, now again I'll apply the Pbar for the regions wherever it is needed. You can just simply click on Nev. Just do the same thing for most of the regions wherever it is needed. Yeah. So here too, this from here to here. There's no Pbar here, so I need to connect it. This point to this point. Just click OK. So it is just taking the grid point IDs into account. Yeah. So we continue the same for all the regions. Easily editable. Yeah. So you can rename the components like rotor and pump likewise. Yeah. So I have just renamed it everything. So these are the two plates which are for optimization. So yeah. Now you can just simply double click on these properties and add the thickness for everything. Uh, for these two plates, I would like to define the thickness as 5 mm. So initially it was 30 mm thick. So now I'll simply take it as 5. And even for another plate also, I'd like to keep it as it is. So with these values, I would like to run one of the NVH analysis, and then based on the results, I would like to vary the thickness, and then like to reduce the mass in short. Yeah, and remaining all shell. So now it's solid analysis, like the solid component analysis. So for that, I would like to keep all the shell components as minimal thickness, that is membrane. If you keep the thickness less than 0.01 or 0.1, so it will be treated as membrane. So it won't impact on the structural analysis or any analysis of the solid components in short. Yeah, just remember that. So once you are done with that, you can activate the filter for the thickness and see whether it is fine or not. If it is same, the rotor and wall I is to change. I'll just do the same. So in short, all the properties P shells related to all the components with thickness 0.001 are neglected. Only the solid components will be taken into account in short. Yeah. Now we can have a look into the properties and material definitions, whatever we have done it. So material, so you could see there are 3 materials. So 2 not assigned, 1 is already assigned, so you can delete 1. Yeah. So 37 is here, so I'll just go to Pbar. Let me see what I have assigned here. I'll delete this one, so this is not applied. 25 and 26 is applied. So in this, the material definition you can check, it is MID1. So I'll just rename it as the fastener name is M14 here. Just approximation, guys, so everywhere it won't be the same. So Pbar properties. Now I have referred the values from the internet. You can just mention the same here. I1 and I2 would like to define it as 9000, so J double of it approximately, so it should be 18,000. So torsional constant it is, so you could see the equation also, it is written there. Yeah, so once you define this, area of the M14 should be 150. Yeah, so these are the properties for the Pbar M14. This is the material. I would like to rename it. So Pbar M14 properties. Yeah, so here you can simply change the MID to 2 because we have only two materials. So here you can define the shear modulus, the value for the steel somewhat around 80,000. Yeah. So for this Pbar property, I'll simply remove this MID1 to 2 because I have already defined the material there, so it will take that. So yep, so for all the Pbars, the PID is 26. That is done. So I'll just activate the draw shell as solid so that you could see how exactly the thickness has been applied for the plates and how the model is going to look like. Yeah, so this is draw beam offset and draw shell as solid. Let us see. So I could see this is the model, and I just wanted to see the preview of the bar, but it is not, but for the P shell it is there. So fine, thickness, that's fine. So we'll proceed further. So I'll activate the structural tab so that I can define the parameters. Optistruct header, I would like to go for modal analysis first, so you can just select normal mode deck. So you could see whatever the inputs needed for the header, so it has automatically generated. If you want, you can copy from whatever the deck we had prepared earlier, so you can simply paste it. So if you want to know more about these all the cards and the deck information, refer my earlier videos. Yeah, so once you define, next thing is to define the EIGRL card to run the normal modal analysis. So here I would like to have it for 15 modes. V1, V2, I'll keep it 0 so that it can give me total 15 modes. So see, now I need to define a subcase. I need to call right. I need to call for modal analysis. So subcase 1. So you need to define the methods as a structure. You can call that, and then analysis also you should call. So it should be normal modes. You can use the drop down and check. All the types of analysis will be listed here. Yeah. So similarly, you can call for the displacement, all, stress, all, and strain, all. Yeah.
Okay, so once you define everything, it's time to define the contact. So for that, I need to select the sets. So here by choosing the filter by area, I'm just selecting the only area where the contact needs to be there. Okay, we can define the output type as grid for the slave, and the master should be surface. In short, it is elements. Okay, remember that. And you don't need to select only the area, you can select entire face also. I've done it in the later time, so you can see that one. So right now this is how it is. So just for your information, how you can define the contacts is what I'm showing. So just select the contact here. So in the contact types, there will be a lot of contact types. So you can just choose the tie contact here for information. So here you need to define the slave set. So plate is the slave and base should be the master. And the distance is 15 mm from the base and plate. So I'm just selecting the gist auto option. So you can even define the search distance if you want, if it is not going to recognize. So total distance is 15, right? You can define that. So now I'll simply edit the same set so that I can include the another side. So you could see this is the again plate base and this is the plate region. Yeah, so yeah, sorry, that was the filter by line, so I'll just select filter by area and this row I'll simply add it here. Once you're done with this, so you can do the same for other components where it is trying to connect. So this should be the supporting base plate at the bottom, and then this should be slave for me. And I'll just hide this, and here this region is the master for me, because here it is going to be welded, and this is the region where which has the very stiff region. So this should be master, and you need to define this as an element. So here I have defined it as grids, but later I'll change it. Okay, so you can just select again the same tie contact. You need to select the node to surface, very important. It is not the surface to surface. If you want, you can even do that, but thus here I recommend, if you are defining the master and slave, slave should be nodes, master should be a surface. In short, elements. Okay. So here pump versus the fitting wall. I'm just selecting the regions. So yeah, the fitting wall should be grids, sleeve, and the bottom pump should be master because where it is going to attach. So yeah, this is how it is done. So here also I'll do the same. So people might be facing difficulties in recognizing which should be the master and slave. It's nothing, you just need to select whatever the region you want, but depending upon the model stiff or it is weak, so depending upon that you can decide which should be the master and which should be the slave. If it is even reversed, doesn't matter. Just remember that. Yeah. Could see everything is done. So I have defined all the contacts. So now the time to define the SPC where it needs to be rusted, right? So it should be fixed in short. So for that, I have selected the SPC. So you can define it. You could see this is the bottom supporting plate, the resting region. So here you can just select the regions where you're gonna bolt it and fix on the ground, right? So this should be completely fixed. All the 6 degrees of freedom should be 0 for me. So you could see once you click on OK, you have the constraint. You should define 1, 2, 3, 4, 5, 6. If you want to free any of this, you can just remove. Like let's say I would like to release Z translation. So 1, 2, 4, 5, 6 you can define like that. Yeah, you could see. So everything 1 to 6 is fixed. Now we have defined SPC also. This I'm not going to consider for the free analysis. So next the frequency analysis I would consider. Now here how I just meshed it with this shell. Now I just need to recognize the volume so that I can do the solid meshing here. So you could see all the volume. So this is the one which is not needed for me, which is inside. What I can do is, which is beyond the scope of my interest right now, so I can simply delete this. So you can just show that, show only, or else you can take this section view and you can just isolate that. That is also fine. So you can just simply activate I0 entity wise, just remove this region so that you can see this. Now just isolate only that and use nearby all function, so which will help you to bring that component back. So now here I'll just select the PID mode, PID region, middle click again. So this is isolated. Now so you have done the I0 option here, so better use all. Okay, now you can just delete this volume. In short, the component will also be deleted. Okay, properties ready to that also. Now my entire model is ready. You can just edit the volume. So here mesh with FEM for the structural. So I'll define the growth rate 1 for each and every components. So why I'm keeping the growth rate 1 is if I keep 1.2, so while meshing, if it goes towards the inside, like the near to origin, so it will try to increase the element size. So if you want, you can even have that, but right now I don't want to have it, so I'll just simply keep the growth rate 1 to keep the element length constant. Okay. By default it is 1.2. If you don't even change it, that's fine. You can simply right click on the volumes and you can mesh, that is also fine. So anyway, but to be precise, so this is what we need to do. Okay, you could see this is the complete solid mesh. Yeah, if you want to take the section mesh, you could see all the constant elements. Now what I told is the slave should be grids and the master should be elements. Now here see it is grids only. What I'll do is I'll just empty this particular set and redefine the element sets. Okay, right click and use the modify contents. Switch from grids to elements here on the top. Yeah, now you select the faces. As I told, you can select whole face instead of selecting the region only. Before I had selected the region itself, right? So likewise. Now middle click, you could see now it's all element sets. Correct? So why I'm doing this is, so while defining the contact, okay, you should have the node to surface contact for the tie. You can even still select the surface to surface, but slave should be here grid and the mask should be elements. Okay, remember that. For that I did the changes. If you don't do that, you might get the error. It shows master ID is not here, it is not recognized, like that. So to avoid that issue, so properly define the sets grid wise and the element wise. Yeah, so once you output the file, so you can import it here. So I'm using Hypermesh 2021. So you could see this is the model. So while opening, you will get some warnings and errors. So you can just go back and fix it. Okay, sometimes you might not have defined the material. It shows material is undefined. Sometimes it shows the set or yeah, sets are undefined. We can go and define them like that. Okay. Now I'll simply activate the Optistruct for the running this analysis. So run option is default optimization. You need to switch to analysis. Okay. Once you click on Optistruct, you just need to replace the model, and here you could see it will run on this the console. Okay. This is the Optistruct computing console solver. You could see the analysis is complete. Now if you want to see the out file, you can go back and see. Now here you can, if you click on the result, so it will take you to hyperview to process the results. You could see all the first 6 degrees of freedom are 0, -3. Okay, in this sense our contacts and connections are perfect, no issues. Now we'll just visualize it by using the post processing in hyperview. Okay, you could see this is the model. You can activate the eigenvalue counter, and you can see, so this is eigenmodes, the behavior with respect to the modes. Okay, I have extracted 15 modes. This is the first one. So as I told, the first 6 degrees are translation and rotation, right, along XYZ. This is what it should show, and this is what it is showing now. Correct? In the sense, our connections are perfectly fine, no issues. So well, this is the next one, the torsion, the sixth one, exact the natural frequency. You could see it is 67 Hertz. So if you have the nuts and bolts with respect to this particular frequency, then it will definitely catastrophic failure for the bolts or whatever it is. This is the bending mode. Yeah, eighth one. So you could see the stiff model, and you could see the plates are vibrating much, right? At the bottom, the 5 mm thin plate. So similarly, if you go the next, you could see again the plate is vibrating much. This is again the torsional, again the bending. Now after 12 or after 10, so these are all the local modes. Yeah, you could see this is completely weak one. It shows the pumping on this particular plate. Later we can try to fix it up. Let's see. We're seeing the here also you could see that plate is not that stiff. So in short, these are the local modes. So with respect to that, you could see how it is behaving, and you can just fix them. Yeah, so you understood, right? So this is how we do the free analysis on the industrial equipment components like the pump assembly. Yeah, so and we have seen how the components are vibrating, or how they are behaving with respect to the frequencies, and we had seen the global modes from 6 to 7 or 8. Okay, all first 3 to 4 modes will be the global modes. All the components will be taken into account, and then if you keep on moving further with respect to increase in the frequency, you will get all the local modes. So with that, you could see how stiff your local components are. So if it is a vibrating much, or if it is exciting much, you could see the modes, and then accordingly you could judge whether this is stiff or not, and then you can go and change the contacts or connections. You can even stiffen it if needed. Yeah, well, so this is about the free analysis. Yep, finally, to conclude, you could see we had gone through the complete model preparation in ANSA, and defining the contacts, connections, and deck preparations, and finally solving the model, and then post-processing the results. So I hope it is clear for you guys. So if you have any doubts or clarifications needed, you can ping us through these contact details which we have given. So you can even mail us, and even you can call us at any time. So if you are looking for the training from our side, we do conduct the personalized trainings for the corporate industries as well as the students. So please free to connect if needed. Yeah, that's all. Thank you.
We heartily thank you all for watching this video. If you enjoyed this video, don't forget to hit the subscribe button and give it a thumbs up. Follow us on Facebook, LinkedIn, and Instagram for behind the scenes content and the updates. Stay curious, stay awesome, and see you again in the next video.